Hey everybody, Kevin here with Onsite Discovery. Here at Onsite Discovery, we help you discover new life for your aging infrastructure. Today we're going to talk about walls, embankment walls to be specific. So, problem with embankment walls is a lot of times the drainage systems that are designed for them when they're constructed fail over time, which creates water either behind the wall or water eroding soil out from behind the wall, because it's seeking the path of least resistance, so it's going to channel and erode the soil. So some examples of walls would be bridge abutments, wing walls, landscaping walls, sheet piling, and also walls inside box culverts. I'm sure there's other kinds of walls, but let's just stick with those for today. So you don't want that water building up behind the wall and putting pressure on the wall. And for instance, behind a bridge abutment, you don't want that water eroding its way out. Reason being is it's going to take soil with it and create voids and basically create safety issues at the roadway, because now you have settlement or holes developing in the road, sinkholes and things like that. So what we're going to talk about today is the jet filter system. And what it is it's a serviceable drain system and filter system for walls. Now these can be designed in a new construction and also retrofitted. So let's imagine we have a culvert, a box culvert, where the water on the outside of the culvert is causing issues with the walls on the inside, either through freeze-thaw, it's causing strain on it, cracking, and then water seeping through, and also, corroding and rusting the steel inside the concrete. We got to get that water drained so that structure will last longer. Okay, so what we're going to do is we're either going to take this would be a retrofit scenario, and if there's existing weep holes that have failed, or if there's not, we're going to core new holes. So what we have here is the jet filter system. Now this is high-grade steel, high-grade plastic construction, and it is designed to be serviceable. So what I'm going to do is I am going to show you piece by piece how this system works. Okay? I'm going to set that over. I have another one here. Each system comes with all the appropriate hardware to mount it. Okay? And it takes a 3/8 inch wrench, or a lot of people use a drill. So what's going to happen is you're going to core your hole. Okay? Now imagine my hand here is the hole that's been cored. This shell system here slides into the core and mounts flush against the wall. Now it's got a rubber flange here to create a good seal, and you can see we have 4 mounting brackets. So these are concrete screws, so it would depend on what you're mounting it to, but they go in and mount to the concrete wall. Okay? Now, so this is the kind of the structural component of it. Then we have these inserts, which are made of a hard plastic containment system in a conical shape with a filter fabric. We have different types of fabric for different types of flows or soils and things like that. So now remember, this thing's mounted up against the wall. This thing here slides right in the front and lines up with the holes. Okay? You can see them lined up with the holes. Then we have faces. We have different types of faces, and I'm going to explain that in a second. This is our standard face. It's just an open hole. And these slide right in. They're machined perfectly, so they only go in one way. And then these mounting bolts here mount it to it. Okay? So now this is what it looks like, and it mounts flush. Tighten them up, and water will come out here. So it's going to come through the core, through the stainless mesh, through the filter fabric, and then out here, and keep all the soil particles back in behind the wall and let the water out, and pretty soon your water levels will go down and decrease the pressure. Okay. So when we're using these products, we're going to space them intermittently. Imagine if this is the wall. So we're going to space them out. Sometimes 5 to 6 feet normally. It depends though, type of material behind the wall, amount of flow you're looking for, amount of water you have, things like that. But we'll work with the manufacturers and the engineers and try to come up with an appropriate spacing distance. Okay, and then periodically, once every couple years or so, depending again on the type of soils and whatnot, your crew will come out, remove the front, pull this out. Likely you'll have some replacement ones just in case, but more times than not, this is still in good shape, and what you'll do is you'll clean this with a toothbrush and reinsert it, put it back together. Okay, so like I said, with box culverts, we've been through quite a few of those in the last year or so, and we've seen extensive damage that many times goes unnoticed because they just sit there underground and rarely get looked at. And what a lot of them are suffering basically underground and need help. And so we highly recommend you use these as retrofits in box culverts. We highly recommend you design them into new structures. Okay, that way, no matter what drainage is behind it, you always have a lifetime serviceable item out front that's accessible without having to dig it up, cause all kinds of downtime to the traveling public if it's a road, or basically you don't have to take the asset out of service to use these. Okay, just we look forward to hearing from you, and thanks for taking the time to watch this. I really do appreciate it. And again, reach out to me, Kevin at onsitediscovery.com, or you can call the number. Thanks again. Have a great day.